Hi students, welcome to our channel Physics Concepts by Ali sir. Now let's discuss about oscillations in this session. So first of all, periodic motion. Periodic motion in sense regular repetition of motion of a particle at a regular intervals of time, means at a particular interval of time if the object is continuing the motion, that motion is called as a periodic motion. The example what we can take, the planets revolving around the sun can be called as the example for the periodic motion. This periodic motion is basically two types. That is a harmonic, non-harmonic. Harmonic in sense if the motion described in a sine and cosine form, then we can say that motion is called as a harmonic motion. So for example, now if we suppose to take if the object is traveling in form of a sine, this is a sine in terms of t is the function, and again the object is expressed in terms of cosine, then this is a cos in terms of t. This type of motion is called as a harmonic motion. The next one is that is non-harmonic motion. So if the object is the object is not expressed in terms of sine and cosine functions, then we can say that is we are calling as a non-harmonic motion. Generally non-harmonic motions we can express like this, or also we can say these are called as a non-harmonic motion. So that's about periodic motion. Next, now let us come to the topic, that is oscillations. What is meant by oscillation? Oscillation in sense then if any one object or any one particle, if it is moving and in a straight line, and afterwards if it is making a to and fro motion, if it is making, then we can say that object is said to be in the oscillatory motion. For oscillatory motion, the particle has to be in a straight line motion, as well as it has to travel a to and fro motion. For example, now if we suppose to take here is any one particle, the particle is traveling towards this side, as well as again it moving towards this side, and apart from that it is traveling even this side. This type of motion is called as oscillatory motion. So this oscillatory motion is there. Why this oscillatory motion? The object is again here is a few terms. Now let us take the object where it is starting, that is we are calling as mean position. This is mean position, and afterwards the object where it is, this is we are calling as extreme position. So both ends we can take extreme position. Here also we can take extreme position, and here also we can take extreme position. The object is traveling. Once the object is moving right from here. For example, now if you suppose to take any one spring, one spring is attached to any one blank. So here is one massive object has been massive block has been kept, and here this object is, once when you are applying the force, this is we are calling as a mean position. Generally mean position represents the letter of O. So once when we applied force, this object will travels towards this side until here it will be. So this is extreme position, we can call it as. The particle won't stops there. Then again, because again the particle starts moving towards main position. So why the particle is moving towards this side is some force is acting on that. That force, the displacement caused here is x we can take, and that is we can call it as F is directly proportional to minus x. Means whatever the object has been made some displacement, the displacement is caused due to the force, and again it is trying to travel towards this side only. So ultimately we can take this is equal to minus k x power n. This is an expression for the oscillation. So that is oscillation. Then what are the examples we can take for the oscillation? Generally then oscillations are also two types of oscillations are there. Linear oscillation, and next one is angular oscillation. Linear oscillation means what that we can take. So this is an example we can take. A spring is suspended and it is making then the to and fro motion. This is one example we can take. And if you suppose to take any one U-shaped tube, and in this one the water is present, and the motion of the movement of the particle, the liquid up and down it is traveling, the liquid is going up as well as it is moving down. This one also we can consider as the linear oscillation. And afterwards angular oscillation. Angular oscillation in sense, then we can take a clock is there. In that clock the second pendulum is there, that is moving towards this side as well as towards this side. This one we can take angular oscillation. And afterwards now let us take any one bowl in the hemisphere. Then in the bowl, if you take any one stone, the stone is moving towards this side as well as it is coming downwards, moving upwards, and this one also we can take angular oscillation. So now among this one, now let's discuss about the simple harmonic motion. So here is a simple harmonic motion. Simple harmonic motion is it is the special case of oscillation. So most of the students are having a wrong conception is a simple harmonic motion is a circular motion. It's not like that. A simple harmonic motion is always it's a straight line motion. A object is or a particle is said to be in a simple harmonic motion if that particle is making to and fro motion in a straight line and its acceleration is directly proportional to the displacement, and it is moving all the time in the against the direction of the displacement, and all the time it moves towards mean position. This is then we can say the object is said to be in the simple harmonic motion. Now let us discuss more detail about this one, the conditions of SHM. So simple harmonic motion. What are the conditions of simple harmonic motion? So for example, now if you suppose, now let us take any particle like this, and if you are taking like this is a simple pendulum, and once when you are applying the force on this, then what will happen? The particle will move towards this side, it makes some x displacement, and so it has an acceleration of a. So the first condition is that particle must do to and fro motion. The particle must do to and fro motion. The second one is that should travel in a straight line. So that has to travel in a straight line. So here it appears as angular, but actually once when we are taking the particle in the microscopic level, the object actually it has to travel in a like this it is, but once when you are going very close, the object starts moving in a straight line only. And next one is this acceleration is all the time directly proportional to the displacement. And minus, this minus indicates that the direction of acceleration is all the time against to the direction of displacement. And next we can consider about this is all the time the acceleration should move direct towards mean position. This is the object. Then if the particle is satisfying these all things, then we can say that is the object is said to be in the simple harmonic motion. So to describe about discuss about the simple harmonic motion, now let us take one circle, reference circle let us take. And so what is a reference circle? So reference circle, through the for explanation of this SHM, then we will take SHM through reference circle. So what is meant by this reference circle? So reference circle, now let us take for example. So if a particle is projecting in any uniform circular motion on the radius, then which it can be called as, then mathematically that can be expressed as the mathematical expression for a simple harmonic motion. What does that mean? The particle is the particle is just moving, so that is projection of a particle in uniform circular motion on the radius, then it directs towards the mean position. That object is said to be an example for the simple harmonic motion. So now let us take one example for this, so we will understand that. So first of all, now let us take any one circle, now let us take, and through the circle let us explain the simple harmonic motion. And for this one, now let us take x axis on x dash, and again let us take on y dash. So this is the mean position. Now let us assume that one particle P is moving on this x axis, and it is making a certain angle of omega. So it is angle is omega t. The angle it is making omega t. Now just draw one perpendicular onto this y dash. So the perpendicular, now let us draw this is. Now let us call this one is M. M is call it as a projection. So here now let us discuss about simple harmonic motion through this the circle and reference circle. So the first of all, if we suppose to take the particle is moving from x dash to y, it is traveling, then the projection will starts from the projection, the particle projection will be O to y. The projection is O to y. So if the particle is the projection is starts from the particle is moving on the circle y to x, the projection will starts from O to, so the projection will start from this particle traveling towards this side, and so the projection will starts from O to y to O, and afterwards the particle starts the projection from x to y dash, then the particle starts from 0 to y dash. So here is the last one. If the particle is traveling y dash to x dash, then we can take the particle is traveling y dash to x dash, in sense the projection will starts from y dash to O. So then what happens here, if you observe, the particle is moving in a circular path as well as it is traveling the projection. So the projection has been taken place based on the movement of the particle. This is we are calling, by means of this we can explain that the simple harmonic motion is executing on any one circular this type of the reference circle. So now let us take the next one, simple harmonic motion. Some important properties of the characteristics of simple harmonic motion. The first one, now let us take, if we are taking omega t here, this one also omega t, and it is making a radius, and again the distance, now let us call this one as y. And so now first of all, now let us take the displacement. So the first one is displacement we can take. So displacement we can express as x, sometimes we can consider even y also, no problem in that. So then what is meant by displacement? The motion of particle in the SHM from the mean position to any one particular position. So the particle is starting from here and is traveling towards here, then we can say that is a displacement we can call it as. So then how it will be, then just what we can take, sin omega t. Sin omega t is equal to what we can take, sin omega t is equal to opposite side by the hypotenuse. So y by a. So then what we can take, y is equal to a sin omega t. So this is we are calling as the displacement. Y is equal to a sin omega t. Whereas y is the displacement, a is the amplitude, and omega is the angular velocity, and t is equal to the time taken to travel that angular velocity. Y is equal to a sin omega t. So now let us go with the next one is velocity. So the what is that velocity? Velocity is equal to rate of change of displacement or distance. V is equal to dx by dt. So then here we can take d by dt of x value, how much is that, or x or y, whatever, there is no problem. We can consider x is equal to a sin omega t also, there is no problem in that. So d by dt of, so x is equal to, then what we can take, a sin omega t. So then here is, then a is the constant. Again d by dt of sin omega t means cos omega t. Again differentiation of omega t, that one also omega. Ultimately what we will get, a omega cos omega t. Consider this is the second equation, v is equal to a omega cos omega t. Then here is an equation we can consider. And afterwards then we can consider, now let us take this for this velocity. Now let us write one more important expression. So the first one is, then what we can take for this one is cos square omega t plus sin square omega t is equal to 1. So then cos square omega t is equal to 1 minus sin square omega t. Then that is equal to 1 minus sin omega t is equal to y by a. So sin square no, so y square by a square. So then what we can consider? A square minus y square by a square. So then what these all things are? This is for a cos square omega t. Cos square omega t. So here is now let us take this cos square omega t. Then we got. Now let us substitute this one, sin square 1 minus sin square omega a square minus y square. So here is now let us take v is equal to. So v is equal to a omega cos square omega t. So then what we can take for this one, that is equal to, instead of cos omega t, if we suppose to take, then what we can take? This one will be cos omega t. So here is a omega square root of a square minus y square by a. Then we can cancel these two. So ultimately what we will get? Omega square root of a square minus y square. This is one of the very popular expression. And so for velocity we have two formulas. We got v is equal to a omega cos omega t, as well as v is equal to omega square root of a square minus y square. So now here is now let's discuss about this one. So here is now this velocity. Now if we suppose to take any one object, so the particle, and here is the mean distance, mean point, mean point. Afterwards the object is mean position. This is extreme position. So and here also extreme position. At mean position x is equal to 0, means the object is starting right that moment. So at extreme position that x is equal to a. Now let's discuss about this volume velocity. Velocity v is equal to omega. So instead of at the mean position, now let us take mean position. If you suppose to take, how much will be that mean position? So mean position. So mean position, how much we can take? Mean position y is equal to, or x is equal to, how much is that? Then we can consider mean position is 0. So y is equal to 0. And this one we can consider as y as well as x. There is no problem in that. Omega square root of a means omega a. So maximum, the velocity is maximum at mean position, that is omega a. At omega is maximum at mean position. Then what about then if you suppose take the extreme position. Extreme position omega x is equal to, how much is that? X is equal to a. Or then what will happen? V is equal to omega square root of a square minus a square, means that is equal to 0. These 2 points has to be kept in mind. So at mean position the velocity is maximum, and at the extreme position velocity is 0. So the next one is, then we will go with the acceleration next. So then what is the acceleration? Acceleration formula actually we can consider from the velocity. What is the formula for acceleration? Acceleration a is equal to dv by dt we can consider. That is equal to d by dt of v value, how much we got? A omega cos omega t. A omega cos omega t, then we can consider. That is equal to a omega is the constants, cos omega t in sense minus sin omega t, and again omega will be again differentiation, so omega will come again. So that is equal to minus a omega square sin omega t. This we can reframe as minus omega square a sin omega t. So this is nothing but a sin omega t. What is that we got? A sin omega t x. So a is equal to minus omega square x or y, whatever may be we can take. So let's take y. Both are similar words, we can consider both, no problem in that. So a is equal to minus omega square y. And here again now let's take 2 extreme conditions. Number 1, it is at a mean position. At mean position x is equal to 0 or y is equal to 0, acceleration becomes a 0. Because 0 multiplication, that will becomes a 0. Then what about the second one at extreme position? At extreme position, so extreme position y remains a y only. So then acceleration is equal to maximum minus omega square y we can consider. So in that way, just we can take the acceleration. Okay, right. These acceleration, these all things now let us. So ultimately, how to keep this in mind? Y is equal to a sin omega t, v is equal to a omega cos omega t, and a is equal to minus omega square y. These all things you have to keep in mind. So now let us take these all things. Let us express this by means of the graph. So the graph, let us express that in terms of x-axis, then we will take a time. 3 graphs we can consider here. The first one is a xt graph, yt graph, or xt graph or yt graph or vt graph, and again now let us go with the third one, acceleration time graph. So now let us discuss about the graphs. So how the graphs will be. So for this one, first of all, now let us go with the xt graph. So for this one, the formula we have to keep x is equal to a sin omega t. Through this one, now let us write the graph. And so here is on x-axis we will take a time. So on y-axis, now let us take x. So the values, now let us start from t is equal to 0. So then what will happen if t is equal to 0? Then x is equal to, how much x will be? X is equal to a sin omega into 0. So that becomes a 0. So here is that starts from the 0. The xt graph, it's starting from the origin. Then that is we can call it as a 0. Now let us take t is equal to pi by 4. Then x is equal to a sin omega means 2 pi by t. T is equal to, also we can consider t by 4, no problem. So t by 4. Here 2 and 2 get cancelled, and 2 and 2 get cancelled. X is equal to a sin pi by 2. So that is equal to, x is equal to a, because 90 is equal to 1. So here is the maximum, this will be here. So it is, this is what we can call it as a maximum point. And afterwards, now let us take t is equal to t by 2. X is equal to a sin 2 pi by t into t by 2. So here t get cancelled, so x is equal to, then how much will be? This entire part becomes 0. So then this becomes 0. So again it reaches to the 0, and here is t is equal to, how much is that? T by 4. And here is t is equal to t by 2. Next now let us take t is equal to 3 t by 2. We are going on adding t by 4. So now let us take t by 2 plus t by 4. That becomes 3t by 2. So here is so LCM 4, 2t plus 3. So this is 3t by 4. So 3t by 4 we can consider. Now let us take about this one. So x is equal to a sin 2 pi by t into 3t by 4. And here t get cancelled and 2 get cancelled. X is equal to a sin 3 pi by 2, that is equal to minus a. So the graph will turns like this, it comes here. And so here is the value has to be taken here a, and this should be taken minus a. Then here next t is equal to, again now let's distribute 3t by 4 plus 4, that becomes 2t. So then x is equal to a sin 2 pi by t into 2t. So tt get cancelled. So 3t by 4 plus 4, no, 3t by 4, 3t by 4 plus t by 4. So 4, now we will take only t. So that time what will happen? This 2 will be. X is equal to a sin 2 pi. So that is again that becomes a 0. So then what will happen? The graph will again reaches towards this side. In this way we can draw the graph, xt graph. This will come like this, and here is the value t is equal to 3t by 4, and here is t is equal to t. So this is a xt graph. Now let us go with the next one, that is a vt graph, velocity time graph. And for this one, now let us take the same, and here is then what equation we have to consider. That equation now, okay, this part, okay, I hope. So the next one, now let us go with the velocity. So for this one, first of all we have to take the expression for velocity. So v is equal to a omega cos omega t. So now let us take starts with t is equal to 0. Then what will happen? V is equal to a omega cos 0. V is equal to a. So the value, and here we can take a omega. So we can consider this is a omega will come. So then the value is a omega. So the graph starts from here for VT graph. Next t, let us take t is equal to t by 4. Then v is equal to a omega cos 2 pi by t into t by 4. So that is a t by 4. T to get cancelled, 2 to get cancelled. So a omega cos pi by 2. So that is equal to 0. So the graph comes starting from here, and here at a t is equal to t by 4. So the graph coming here is a 0, and of course this is 0 we can consider. Next t is equal to t by 2. Then v is equal to a omega cos 2 pi by t into t by 2. So t get cancelled, cos this one is, this is cos pi will come, that is equal to minus a omega. So the graph can express like this, and so here is then what we can take here, we can consider this is minus a omega. Next we can go with t is equal to 3t by 4. Then v is equal to a omega cos 2 pi by t into 3t by 4. So t to get cancelled, 2 to get cancelled, v is equal to a omega cos 3 pi by 2, that is equal to 0. And so the graph again it will come here like this. So this is at t is equal to 3t by 4. Now let's go with t is equal to 2t. So 3t by 4 plus 4 instance t is equal to t we can get. So then v is equal to a omega cos 2 pi by t into t. T to get cancelled, cos, so that is equal to a omega cos 2 pi, that is equal to a omega. And so the value, and here is t is equal to t. In this way the graph is for the velocity time graph. Next now let us go with the third one, that is acceleration time graph. So in the acceleration time graph, so for acceleration time graph what formula we have to take? Then we have to consider so then what is the formula we got for acceleration? A is equal to minus a omega square cos omega t. So this is the equation. Then what we have got for this one? Now let us see. And so for this one, first of all, now let us take t is equal to, let's start with 0. So a is equal to how much will be? Minus a omega square. So then what will happen? The graph will start from here. So the graph starts from in the minus. So that is a is equal to t is equal to cos 0 is 1. So that starts with minus. minus a omega square. So here is that graph, here is then we can take this is a omega square plus this is minus a omega square. So the graph will start from here because t we have taken 0. So now one moment, now let us see. X is equal to a sin omega t, v is equal to a cos omega t, a is a omega. So a is equal to a omega t minus a omega square sin omega t. So this is the small correction. So a omega square sin omega t. So t is equal to, then what will be that time? Then what we can get? A is equal to, so if I was supposed to take so that is also, then we can consider. If t is equal to 0, then a is equal to sin 0, 0. So this graph also will starts from here. So it start from here, and afterwards if t is equal to pi by 4, so a is equal to minus a omega square sin 2 pi by t into t by 4 we can consider, t by 4, and t to get cancelled, 2 to get cancelled, that is equal to minus a omega square sin pi by 2. So that becomes minus a omega square. So then minus sin omega square in sense the graph t is equal to 0, then so we have to consider right from this side. The graph will come like this, and afterwards then we can consider if t is equal to pi by 4 we have completed. So now let us take t is equal to t by t. A is equal to minus a omega square sin 2 pi by t into t by 2. So t to get cancelled, 2 to get cancelled. So that becomes minus a omega square sin pi in sense that will becomes 0. So then here is the value starts from here. So at here this is equal to 0, t is equal to 0, and t is equal to t by 4, at t is equal to t by 2, and again now let us take this one, t is equal to 3t by 4, then a is equal to a omega square we can get, and so the graph will come like this, and afterwards at t is equal to t, then a again will get the acceleration becomes 0. So the graph will becomes like this, and so here is t is equal to 3t by 4, and here t is equal to, then we can consider as t is equal to t. In this way we can take a graph for these three xt graph, vt graph and at graph. These three graphs are the most important from the point of view as well as in the competitive also. So this is about the graphs how they have been. Next one, some important terms based on this one. Now let us discuss. In that one, the first one is amplitude. What is meant by amplitude? Maximum displacement caused by a particle in the simple harmonic motion. If any one particle is there in the simple harmonic motion, how much maximum displacement it causes, that is we can call it as the amplitude. The next one is time period. So the time period generally represents the letter of t. T is equal to, then we can consider omega. This one can be expressed by means of the omega is equal to 2 pi by t. Then we can consider t is equal to 2 pi by omega. So this is what we can consider as for a time period. Next one we can go with the frequency. Frequency is equal to reciprocal of a time period, that is equal to omega by 2 pi we can consider. This is about the terms which related with the amplitude, time period and the frequency. So the next one we can go with the phase and phase difference. So then what is meant by phase? Phase in sense generally the phase. So here is now let us take one expression. X is equal to a sin omega t plus phi. So this can be expressed. What is meant by that? This omega t plus phi is called phase. So phase in sense, the phase it explains about the position of the particle in the SHM from the mean position. So if we suppose to take one example. Now let us take here is now let us take again any one spring mass system. So very beginning it is like this, and afterwards then again if we suppose to apply some force on this, then this turns into till this part, and again due to that retardation again it will comes towards this one. So here is the mean position at here phi is equal to 0. Before that we will discuss what these are terms. Omega t plus phi is called as a phase, whereas omega is the angular velocity and t is the time taken for that angular velocity, and phi is the phase difference. So initial phase phi is not phase difference, phi is initial phase. Initial phase in sense what is that? The particle where it is. So for example, if the particle it is here this spring, this mass is not moving, so that phase is equal to 0 we can consider, because there is no motion for this one. So we can consider this is equal to x is equal to, we can consider as a sin omega t. That's it. Why we have not taken the 0 is because the phase is nothing, the phase is not there, phase is equal to 0 because the particles did not start, it's its original mean position then afterwards. So if it is making, and from here if we are supposed to observe, it has made some distance. So now let us take it has made some phi phase. Then in such case then what we can take, this is equal to, this is pi by 2. In such case the equation turns like this, x is equal to a sin omega t plus pi by 2. So again afterwards then what happened, the base of this one again it is making some distance towards this side. In this case that is this is the mean position, this is extreme position, extreme right side position, this is extreme left side position. So here then we can consider here is then this phi is equal to minus pi by 2. So here is x is equal to a sin of omega t minus pi by 2, then we can consider. So now let's discuss more about this one. For example, if any one particle is at mean position, it is traveling and so at phi is equal to 0 to this, it is travels towards this side, so it is traveling pi by 2, its phase is pi by 2. So now let us assume that this is it covers a displacement of a. So again it is traveling towards this side, so it is at a at phi is equal at mean position, again this will be considered phi is equal to then pi. So again if it is traveling like this, then again it is a right extreme, this is the right extreme, this is left extreme. In the left extreme then what we can take, this is equal to phi is equal to, so here is again it traveled a, and again here is pi is equal to, again what we can consider pi 3 pi by 2, and also we can say minus pi by 2. So then again the particle will start traveling towards this side from here to here. Then what we can take, phi is equal to, then we can consider, so 2 pi also we can say that is equal to 0. Means if it is traveling towards a and here is here. And so from the mean position till here it is making, so the first turn that is equal to first phase A. And afterwards it is traveling towards this side, this one also A, and afterwards it is traveling towards this side, this is A, and again the particle is traveling towards this side A. Total how much is the displacement, how much is the phase we can consider for A, because total if we suppose to take right from here we have to start, then it is traveling towards this side A, and right from there here to here mean position again A, and this side this also. So in this way just we can take about the phase. If we know about the phase, then we can know the displacement, acceleration and even velocity of the particle in the SHM. So now let us take with the phase difference. Then what is meant by phase difference? Now let us take one example. X is equal to a sin omega t, and x1 is equal to a sin omega t plus phi. Then it is asked to find out phase difference. Phase difference in sense what we have to do? We have to take the phase and we have to compare those two. So omega t plus phi minus omega t. This omega t get cancelled. Ultimately, how much is left to us? Now let us take this is a pi by 2, for example, or pi by 6. So phi is equal to how much is the phase difference now? That is equal to pi by 6. And one more example, let's take. If x is equal to a sin omega t given, x dash is equal to a cos omega t given. In this case, then how can you find out the phase difference? Then what we have to do is we should take this both expression should be taken into the same angles. So then what we can take for this one? X dash can be written as a sin of omega t plus pi by 2, because sin 90 plus theta cos theta. So then when we comparing these two, then again what will be the phase now? Phase difference, then we can consider delta phi is equal to omega t plus pi by 2 minus omega t. And here omega t get cancelled. Then what will be the left? The phase difference is equal to pi by 2 when we can consider. Okay, now in this way we can find out the phase difference also. Okay, right. Next one, now let us go with the energy. So what is meant by energy? Those all things, the capacity to do work is called energy. Those all things, okay. But in this session we will discuss about the two, of course the resultant also, the kinetic energy, and again we will consider about potential energy and net energy. So the first one, now let us go with the potential kinetic energy. So then what is the formula for kinetic energy? K is equal to half m v square. Then v is equal to what we have got? A omega cos omega t. So then Ke is equal to half m v square, no? So a square omega square cos square omega t. So here now let us take Ke is equal to half this part m a square we can consider as m omega square. M omega square into a square cos square omega t. Now let us take cos square omega t. So m omega square can be called as a k. So Ke is equal to half k a square cos square omega t can be written as 1 minus sin square omega t. So sin omega t is equal to y, so K is equal to half k a square 1 minus y square by a square we can consider. This is the projectile, so that we have taken reference circle from this one. Now we can take, so the particle is in the projecting this side, the projectile motion, that time it is consisting of, it is a traveling with omega, it is making a omega t. We are just making a projection here. So it is a and so it is a traveling y. From this one also we can consider as omega t. So sin omega t is equal to y by a. This one we can consider. So Ke is equal to half k a square. So this we can consider as a square minus y square by a square. So a square get cancelled. Ke is equal to half k into a square minus y square. Now this is the very popular expression. Then what we can consider, and for this one two things also. Now let us take for this, for example, now here is if we suppose take this is the main position. So here x is equal to 0, no displacement. So this is the extreme position. So x is equal to a. Now let us consider the kinetic energy, how it is in the main position as well as in the extreme position. So now if you suppose take first mean position, now let us take. So if we suppose take a mean position, so how much will be that one? So x is equal to, so we can consider as y also. So y is equal to 0. Now let's consider here also y. So there will be no confusion exist. So then y is equal to 0. Then kinetic energy K is equal to half K into a square, because y is equal to 0. So this is the maximum. So where the kinetic energy is maximum? The kinetic energy is maximum at a mean position. So if we then again, now let's take, for example, if you are supposed to take a graph. So this is a kinetic energy, this is the mean extreme position, this is. So this is a extreme position. So this is a mean position, and again this is a extreme position. So at extreme position, so this is a extreme position, how much is that? That is a 0. Extreme position is a, that is equal to maximum. So then what we can consider, that is a, so the graph will becomes the extreme position, this is a, so at here that we can take this is the KE, what we can take extreme position. Then what about mean position? Now let us take mean position. Y is equal to how much is that? Y is equal to A at a extreme position. Mean position, that is a maximum, so it is going like this. And again mean position, then already we have taken mean position here. Now let us take the extreme position. Extreme position, y is equal to A, so K is equal to how much is that? Half K into A square minus A square. So that is equal to how much is that? That is equal to 0. So here is that mean position, this is equal to 0. That is about the graph even for energy, for kinetic energy. So here is the kinetic energy traveling towards this side, and again of course this side. Both the sides extreme position, the graph is equal to 0. Now that is about kinetic energy. Now let us take about the potential energy. So if we suppose to take potential energy, the expression what we can get for a potential energy, P is equal to how much? For W is equal to Fs, if we suppose to take. So F is equal to, then what we can take? MA, and also we can take F is equal to minus Kx. So MA is equal to minus Kx. So M by K is equal to X by A. Then from this one what we can get? So W is equal to Fs. So W is equal to Fs, we can take instead of F what we can take? MA into Kx we can take. So W is equal to F is equal to, then we can consider MA M by K into X by A. So W is equal to Fs, we can consider F is equal to, then dW is equal to F into ds. F is equal to how much we got? Kx ds. So for this one we can consider, so K is equal to, so omega is equal to, then what we can consider? Omega is equal to K by A. So here is then K is equal to omega square A. Then K is equal to omega square A x dx. Then here is now let us take this is dw. Now let us do the integration. So then we can get integral dw is equal to integral omega square A x dx. So here is that is equal to omega square A into, then what we will get? X square by 2, that 0 to x we can do. So that is equal to omega square A x square by 2. Ultimately omega square A means K we can consider, K into x square by 2 we can get. This is work done. Work done is nothing but potential energy. So potential energy is equal to K into x square by 2. So this is the formula what we can consider. So kinetic energy is equal to half m half k into x square minus a square of a square minus b square, sorry. And so the kinetic energy, then K is equal to half k into a square minus y square or x square, what we can consider. So the potential energy is equal to half k x square or y square, both we can consider. So here is now let's take both the potential energy as well as the kinetic energy we have taken like this. Then afterwards, then we can consider the potential energy. So at mean position, y is equal to 0. Y is equal to 0. So at a mean position, y is equal to 0. So p is equal to 0. So then what will be that one? Then what we can take for that? Then the mean position we can take at mean position, that is equal to 0. Then we can consider at mean position that is equal to 0. At extreme position, how much is that? Y is equal to y, p is equal to 1 by 2 k y square. And so here is the mean position at here we can get, that is this graph we can consider for the potential energy. This is the potential energy graph what we can take. Because this is an extreme position, at a mean position that is equal to 0 potential energy, extreme position that becomes 0. Then a total energy, how much will be that? Total energy is equal to P plus KE we can consider. So here is now let us take the total energy. The total energy is P total energy. So total energy is equal to PE plus KE. So PE is equal to how much is that? 1 by 2 k a square minus 1 by 2 k y square plus k is equal to how much? Half k y square. These both get cancelled. Ultimately, how much will be that? Half k a square. This is a total energy we can consider is half k a square. This half k a square is at a mean position, and again we can, there is no expression about this x or y. So in this way just we can calculate the different energies, potential energy, kinetic energy and total energies of this. So okay, next one is, now let's go with the next one, that is system executing harmonic motions. In that one, first of all, now let us take about the first one, restoring force. So what is meant by restoring force? So restoring force in sense the force gained by the body by removing the external force, means now let us take a restoring force. Now let us take any one spring mass system. So in this one, once when we are applying a force on this, the particle will go down, and again once when the force is released, means the applied force is removed, again it starts traveling towards this side. So this force is called as restoring force. Then we can consider F is equal to minus k into x. For this one, this type of once this restoring force in sense, we will suspend any one mass through a spring. So then we will get, so for this one, then we can get this type of objects, then we will get the force time period is equal to 2 pi root m by k. So this expression we can get for the time period of this one, t is equal to 2 pi square root of m by k. Now here is this is for a restoring force expression what we can take for this one, and time period for any this type of suspended objects. So now here is, now let's go with the next one. Once we are taking the springs, when we are connecting the springs in the series, in the parallel as well as in the series, how much is the resultant force? Now we will see. And so once the springs are connected in the parallel, once the springs are connected in the parallel, how that will be? Now here is, so let us take two springs we have taken. Now we have taken, this is any one object. These two springs, now let us take, this is a K1, this is a K2, the constants. So here is the springs, once when we are taking, once when we are applying the force on this, then what will happen? The springs will come down, the mass of the object will come down, as well as again it will goes up. And here then what will be that once when they are in the parallel, so now we can consider the displacement is constant. Displacement constant. Displacement is constant. Then what is changing? Force is changing. F is changing. Then in such case for this one how much will be that? F1 is equal to minus k x1. F2 is equal to minus k x2. So net force F net is equal to what will be that one? So F1 plus F2. F net is equal to minus kx. So that is equal to minus k x1 minus k x2. Then what you will get? Here is the x is the displacement is constant we are taking, and so then we can consider. So here is equal to k1. This is k1, k2. These constants are changing. So here is a k1, k2 we can consider. So k parallel is equal to x will get cancelled, minus minus minus, and x get cancelled. Then what will be left? K1 plus k2. So the same we can apply formula here is T is equal to 2 pi m by k in sense k1 plus k2. What we can get? This is one of the very important expression. And afterwards now if you suppose this is about a parallel. Now if you suppose to take so this is a series. Then when we are taking about a series, now let us take two springs, and here is one spring, and afterwards then we have taken another spring. These two have been connected by any one mass once when are pulling this side. In that case then what will be the constant? That is the force is constant. And again here is now let's take k1, k2, and here is then what will be the changing? The displacement is changing. And so then what will be? F is equal to minus k into x, and here is x is equal to x1 plus x2. So x is equal to minus f by k. F is constant. F is equal to f1 is equal to f2. Then x1 is equal to minus f by k1. x2 is equal to minus f by k2. Then what you will get now? X is equal to, then we have taken f is equal to, how much we got? Minus f is equal to the, so we have take this expression, x is equal to minus f by k. Minus f by k is equal to minus f by k1 minus f by k2 we can consider. What you will get? 1 by k is equal to minus get cancelled and f also get cancelled. 1 by k is equal to 1 by k1 plus 1 by k2. So this one we can consider as 1 by k is equal to k1 plus k2 by k1 k2. So k is equal to how much is that? k1 k2 by k1 plus k2 we can consider. T is equal to 2 pi root m by k formula we can apply. So m by k, so m by k, so reciprocal k1 plus k2 by k1 k2. So in this way just we can consider about the springs are connected in the series as well as in the parallel. These are the two important expressions for that. And next one is, now let's go with the time period of a simple pendulum. So now let us take one simple pendulum. Now let us find the time period of a simple pendulum. So for this one, first of all, now let us take any simple pendulum whose mass is L and its length is L. Once when we are applying the force, the simple pendulum starts moving towards this side. So it will make some distance. Now let's assume that the distance is x. So here is this is mass, and so then what will happen? This will cause us mg, the gravitational force acting on that weight acting downwards. Then we can take two components. Then this side generally this is the theta. So mg cos theta. That will be this is mg sin theta. So here is theta. So we can consider that one also theta. Here mg cos theta makes the particle to maintain the tension, and here is the tension of the particle, and mg sin theta makes the object to move in the motion. So then we can consider here is mg ma is equal to mg sin theta we can consider. So both sides mass get cancels. A is equal to g sin theta. Sin theta means how much we can get. So opposite side by this one. So x by L. Then here is t is equal to. So here is then we can consider A is equal to g into x by L. So for this particle then we have to take the time period. So time period t is equal to 2 pi root x by A. This expression very beginning we have got that one. So that is equal to 2 pi x by A value how much is that? G into x by L. These are square root. This one get cancelled. Ultimately 2 pi root L by G. So this is the time period for a simple pendulum. T is equal to 2 pi root L by G, whereas L is the length of the string, G is the acceleration due to the gravity. So now let's take some special cases of a simple pendulum. Where are those? What are those special cases we can consider? So the first one is a simple pendulum when it is then revolving. And next one, once if anyone, so this is what first one we can take. The second one, if we suppose take any one liquid which is viscous and not which is viscous. Okay, right, this will take. In such case, liquid which is viscous in a U tube. So now let us take any one U tube. In this one, now if we suppose to take this liquid we have taken this side and this side as well as. Now let us take this is the height of the liquid. In such case, T is equal to 2 pi root h by g. This is important formula. So this is for if a liquid in viscous liquid is there, if it is moving in any one U tube, that time the time period of that liquid is equal to, then we can consider T is equal to 2 pi root h by g. Next one, then we can consider about if any one bowl is hemisphere bowl is there. Hemisphere bowl. So with radius of r, a ball with radius of r is moving inside, moving. So for that ball, time period is equal to 2 pi root r minus r by g. Whereas r is the radius of the ball, small r is equal to radius of the ball. This is the straight formula we can consider. And afterwards, now again we can consider about. So here the object is the if we suppose to take a tunnel. So if the earth tunnel is there, in that one, in the tunnel, if a ball is going in that, in such case in the tunnel the formula T is equal to 2 pi r by g, whereas r is the radius of the earth. So through the tunnel, if the object is traveling, this formula we can use. And afterwards, next one is any one string, elastic string is there, so which is making some vibrations. In such case, T is equal to 2 pi root ml by a y. So this is we can consider as the time period for the any one string is there. In the string, the time period what it is taking place. So here is m is the m, l, a, y. These all things we can consider. So mass of the string, l is length of the string, area of the string, and y is the Young's modulus. So that one we can consider about the different terms which we are using for the simple pendulum. Okay, right. So the next one is now differentiation. After completing that, now let us go with the differentiation form of simple harmonic motion. So differentiation form, it's important. Differentiation form, now objective, very oftenly it is coming. So the differentiation form of differentiation form of SHM. Differentiation form of SHM, dx square by dt square plus kx is equal to 0. That we can take a differentiation form of the SHM. Next, damped vibrations. So then what is meant by these damped vibrations? Damped oscillations. Damped oscillation motion, DOM. Damped oscillations motion also, now let us take. So this one, then this is what is meant by damped oscillation. So if any one particle is in the vibration, so it is making a to and fro motion. Due to many reasons, if it is in the vacuum, that vibrations are infinite, there is no end, that is continuously going on. But whereas in case of the planet Earth, which is surrounded by atmosphere, so air friction is there. Because of that, that vibration starts slowing down. That type of vibrations we used to call it as damped vibrations. Damped vibrations in sense the vibrations which are reducing the amplitude, that we can call it as damped vibrations. So for this damped vibrations, that is we are calling as a damped vibration. And next one is forced vibrations. Forced vibrations. So under the external force, if any one body is making vibrations, such vibrations are called as forced vibrations. Next one is a free vibration. If any one system is in the equilibrium state, if it is making the vibrations on its own, such type of vibrations are called as the free vibrations. The next one is resonance. Resonance in sense, if every body is having its own frequency, natural frequency we used to call it as. If that the body frequency is, if an external force acts on that given frequency, this natural frequency, both are coming into the same phase, means those frequencies, both the frequencies are the same amplitude, then they starts moving with the maximum amplitude. For example, that's we are calling as resonance. For example, one bridge is there. That bridge is having some natural vibration. So army is going on that, they are doing the march fast. So the march fast of that army vibrations and again these the bridge vibrations, both are just becoming same. They use the bridge starts moving with the maximum vibration. So this is we are calling as the resonance. Next one is superimpose. So the if this is about the resonance, then superimpose of oscillations. So what is the meant by these superimpose of oscillations? So for example, now let us take any two simple harmonic motion, A sin omega t, and another particle is there, that is having, so that is equal to A sin omega t plus phi. So these are the two simple harmonic motions, expressions of two different particles. If these two particles are superimposing, and they are just combining, mixing, in such case the resultant amplitude A is equal to square root of A1 square plus A2 square plus 2A1 A2 cos phi. So this is what we are calling as the superimposition, the maximum amplitude, how it can be. Okay, I hope that this session is helpful for you. Please support me, Nana. Wish you all the best.